So hi everyone, in this video I am going to solve this particular problem on GFG. The name of the problem is max Xor Subarray of size k. Let's see what this problem is saying. So we'll be given an array of integer that will be denoted by ARR and a number k. Return the maximum Xor of the subarray of size k. So out of all the subarrays of size k, we need to find which one is going to give us the maximum Xor. So let's take the first one as an example. So all the subarrays of size k will be 258, 581, then there will be 811, then there will be 1 1 and 3. So these are the four subarrays that we'll be getting that are of size k, and if we try to calculate the Xor of this, then what would be the Xor? So 2 will be represented as 1 and 0, 5 is 4 and 1, so that is 2, this is 5, and if we Xor them, then what is going to be the result? So the Xor of 2 and 5 will be 7, and if we Xor it with 8, then it will give us 15. Again, if we try to Xor 5 with 8, so 5 is 101 and 8 is 1 is so the bitwise representation of 8 is 1 0 0 0. So if we try to Xor it with 5, then it will give us 1 1 0 1, and if we again try to Xor it with 1, then it will give us 0 0 1 1. So this is 1 2 4 8, so this will give us 12. And if we try to Xor 8 with 1, then it will give us so the bitwise representation of 8 is 1 and then 3 zeros. The bitwise representation of 1 is 1, so if we try to Xor them, then it will give us 9. And if we again try to Xor it with 1, then it will again give us 8. Similarly, this one will give us 3, because this 1 and 1 will be cancelled out if we try to Xor them altogether. So if we see, then this one is the one that is giving us the maximum Xor. So we can say that this is the maximum Xor we are getting, and this will be the answer. So in the output, they are giving this one as the answer. So this is the approach that we can follow. We can create all the subarrays at the very beginning. So the first step will be create all subarray of size k, and the step 2 will be to calculate the Xor of the created subarray. And out of all these subarrays, which one will give us the maximum XOR? We'll be saying that that is the answer. So this is one step we can do. Like this is one approach that we can follow. But what is the drawback of this approach? So basically, if we see the constraints over here, it is saying that the array size could go up to 10 to the 6. So if we say that there are n number of elements in the array, then we can say that the value of n can be as big as 10 to the 6. And since k can also be as big as the array size that is n, then we can say that okay, k can also go as big as 10 to the 6. So if we see n can go up to 10 to the 6, k can also go up to 10 to the 6. And since this approach is telling us that we need to first create all the subarrays, so creating all the subarrays mean we are going to create n minus k number of subarrays, and for each of the subarrays we are again going to iterate to calculate the number of, like to calculate the XOR of the resultant subarray. So in total we are going to make n minus k multiplied by k operations. So this is going to be this one is going to be big of n multiplied by k. If we try to break it down in a simpler form, then we'll be able to understand in a better way. Minus k square. So depending on the values, this is going to be the time complexity. Now since n and k, both of them can go as big as n, like 10 to the 6, so you can say that the time complexity will be roughly around 10 to the 12, which is much bigger than 10 to the 8. So we need to find a more optimized way. So if we try to look at it in from a different perspective, then we'll be able to see that we can use something similar to sliding window. But how we are going to calculate the subarray XOR, and that is a challenge. Let's see how can we solve this one by using sliding window. 258113, that is the example array. So if we keep a window of 3 size, then the first window will be containing the first 3 numbers, 2, 5 and 8. And suppose if we have calculated the XOR of them, and now we want to eliminate this 2 from here, and instead we want to add the element from here to the window. So if we want to create this window, so 5 should be there, 8 should be there. What is going to be eliminated? 2 will be eliminated, and the new element 1 will be added. So suppose it has a XOR value of, what was the XOR value? So this has a XOR of 15. So if we XOR all 3 of them, then this window will be containing 3 elements, which will give us a total XOR of 15. So now if we try to modify this in a way so that we can calculate the XOR of this window without revisiting each and every element in the window. Can we do that? Yes, of course we can. Let's see how. So basically we need to eliminate this 2. So eliminating this 2 means basically do a XOR operation with 2 again. What does that mean? So basically if we see 2, 5 and 8, this were the element in the window. If we again XOR it with 2, then this 2 will be cancelled out with this 2, right? So we'll be left with 5 and 8. And again, if we XOR with 1, then we'll be left with 5, 8 and 1, and that's what we need. So basically, we need to XOR it with the element that is just at the right of the window, and we need to XOR it with the one element that is at the starting of the window, or the leftmost element of the window. So basically, the first time we need to create a total XOR that is there for the first subarray, and then for the respective window, what do we need to do? We need to just perform XOR operation on the left most element of the window with the element that is just right to the window. So since we have created a new window, and the resultant XOR will be the XOR of 5, 8 and 1, suppose we want to move forward and add this element as well to our window. So 8, 1 and 1. So if we want to add 1 to its XOR, then we need to XOR it with 1. And if we want to eliminate 5, then again we need to XOR 5 with the result. That's how 5 and 5 will be eliminated, and will be left with the XOR of this 3 number. I hope it makes sense. And then again, if we want to eliminate 8 from the window and create a new window, we are not creating a new window, we are just sliding the window. Basically, we are taking the right element and adding it to the window, and we are eliminating the leftmost element from the window. So 8 is the leftmost element. We are not going to add 8 anymore. We are just going to keep these 3 as the window element. So again the same thing, 8, 1, 1 were present in the previous window. What do we need to do? We need to again XOR it with the left one. This will cancel out this 2, and we need to again XOR it with the right element, this one element, so that we get a resultant that will contain the XOR of this 3 element. So at each step we are going to compare it with the previous one, if that is giving us a better answer or not. Then after we have gone through all the elements, we can say that we have calculated the XOR for each of the subarray of size k, and that answer that we got at the end, that will be the maximum out of those. So let's code it up to understand it in a better way. So let's say n is the size of the array. We are going to keep track of the window either by using a queue or by using a left and right pointer. Since queue is going to use additional space, we don't recommend it, like we are not recommended to use queue. But since we have already used 2 pointer in our previous solution, I will be using a queue in this solution. And the current XOR will be stored in a variable. Let's say current XOR, which will be initialized to 0, and again we are going to compare this current XOR with the answer and finally return the answer. So we are going to iterate through each and every element, and we are going to insert this element in the queue, and we'll be performing XOR operation with this element to the current XOR. So current XOR will now become the resultant of the XOR operation of current XOR with A. Now we are going to check if this size of the queue is exceeding the size k. Then what do we need to do? We need to eliminate the element that is on the left of the queue, and to eliminate it, what is the process? We need to again perform XOR operation. So current XOR now we are going to check if the current queue size is exactly equal to k. Then what we are going to do? We are going to basically check if the current XOR is greater than the answer. So then we'll be returning the answer in the end. Yeah, it is passing the example test case. Let's see if it is passing all the test cases. Yeah, so it is passing all the test cases. Since we have used a queue over here, so the space complexity will be big of k, because at any point of time we are going to store at max k number of element. So the space complexity will be big of k, but instead if we have used 2 pointer, it could become big of 1, that is constant, and the time complexity of this approach is big of n plus k. So let's say k is equal to n, then it will be big of 2n, which is same as big of n. So that is the space complexity, that is the time complexity, and that is the space complexity if we have used 2 pointer.